All right. Hi, everyone. Welcome to another class on SQL databases. We've already gone through this track, but this video is going to be about some advanced points that we skimmed through / had to go through really quickly at the end of the live class, specifically relationships and joins. Point 1 to 9 we've discussed fairly well. I'm still going to recap them. The focus would be on relationships and joins. Let's get right into it. To quickly recap, in our SQL databases classes, we number one discussed the types of databases. There are 4 broad types that I showed. There are actually multiple types of databases, but the most popular ones that you'll use in a full stack application or otherwise, number one, NoSQL databases. They are schemaless and extremely lean and fast. And by fast, I mean very fast for you to iterate as a developer. You can have a very lean schema. You can put any data that you want in here. Population can be a number over here, can be a string over here. The number of keys over here can be different from the number of keys in a different row. Extremely schemaless, extremely what's called non-strict, which is the best way to create a hackathon project, best way to quickly start a backend application. This is one of the reasons that MongoDB is the preferred choice when you're just starting to code. Number 2, graph databases. Neo4j is a popular graph database, and the goal of a graph database is when you have extremely high number of relationships. If you want to quickly find who is, for example, a friend of who in a social network like application, or who likes a certain post, if there are such relationships that you can connect similar to a graph, is when a graph database becomes very popular. A common use case is social networks, where you have to keep track of who has liked this specific post or who is a friend of another person. Very easy for you to maintain relationships. The relationships are a first class citizen of a graph database. That is when you want to prefer using a graph database. You don't usually use this for a long time unless you have a very big social networking application, or very big application where relationships become extremely important and fast for you to query. Number 3, vector databases. Not going to go deep into this. I discussed this a little bit in the end of the last class. This is suddenly super important today because of AI. One very popular use case of AI is something called RAG, Retrieval Augmented Generation, or something else. The goal of which is for you to be able to talk to a PDF, talk to a video, talk to a website, like understand what the website says. And for them, vector databases are a very popular use case. What are vector databases? Vector databases let you store some text and an associated vector with them. If you don't understand this is fine, but high level, let's say this text says my name is Harkirat. Before you actually put this in the vector database, you put the text into something called an embedding model, which spits out a vector, and then you finally store a vector along with the original text in the database. We can dive deeper into this into another video. I'm not going too deep into it, but very popular today thanks to AI being on the forefront and these applications, RAG becoming a very important use case, and a lot of companies raising a lot of money, being like a web open source vector database, Pinecone being one of them. There are like 10 different startups that have come up in the last 1 year that have raised a lot of money, the goal of which is they are vector databases. Just how MongoDB is a NoSQL database, Neo4j is a graph database, Pinecone and a bunch of other popular vector databases have suddenly come up, but not the goal of this video. What is the goal of this video? SQL databases. SQL databases let you store data in the form of rows. For example, something like this. This can be a table of mine which has multiple rows. This table specifically contains, let's say, a list of my users. John Doe is a user. This is their phone number, and this is the country they stay in, so on and so forth. Common examples are MySQL and Postgres, and most full stack applications. If you're building a good scalable application, you want to use an SQL database compared to a NoSQL database, which is something we used for the longest time. MongoDB is what we introduced the course with, but SQL is what you want to generally, work with. And as your application grows, SQL databases is what you want to prefer using in your application. Cool. The first question we discussed was why not NoSQL? And the answer was, NoSQL is extremely schemaless. If you use a NoSQL database, your database will allow you, you can put balance as a key here. Let's say this is the Paytm example. I can put amount balance as a key here. I can put balance Harkirat as a key here. There are no checks on the database level. The balance is the only key that's present here and it should be a number. The developer of the application could write some bad code that would allow the database to put amount balance in, or a different key in, string in, RNS data in. There are no strict checks up front at the database level, which is good if you want to, as I said, quickly iterate, but gets bad at scale because your database becomes very unsafe. You can put any data in your database, irrespective of what you might want in there. For example, balance should, if someone's Paytm balance, should never be a number. It should never be Harkirat. But you cannot enforce that at the database level. If I open MongoDB Compass right now and open a database and start to edit it, I can put whatever I want there. SQL databases don't allow that. SQL databases are very strict. They say, bhaiya, if balance is a number, balance is a number. You cannot open a GUI like this, connect to a database, and make balance a string, or balance change this key to something else. Excuse me. Which is why they're usually preferred at scale. Problems can lead to inconsistent databases, can cause runtime errors. What are runtime errors? Okay, bhai, if the Node.js application expects balance to be a key here, but you return it amount balance, the Node.js application might panic. If you return it a string and it tries to parse the string because it thought, okay, this is a number. So if it tried to run a function on this, which it expected a number for, but it got back a string, that will throw an error. So it can lead to runtime errors, can lead to inconsistent databases. And I can go into a database if it was running for me locally, connect to it and change whatever data I want inside. I don't have one running locally, which is why I cannot connect, but you get the idea. I can connect to it, change the data to whatever I want, change the schema to whatever I want. It is too flexible for an app that needs strictness. If you want your application to be extremely strict, and by strict I mean you need things like these to be enforced. Balance cannot be a string. Then NoSQL is not the best option. Upsides, you can move very fast. You can change the schema very easily. Cool. There's a good call out here we discussed in the class. Not going through it, but read through it. Why SQL? SQL databases have a strict schema. They require you to define your schema. What does define your schema mean? It means they first ask you, okay, bhai, what does this balances table look like? Does it have a user ID? Okay, what is the type of the user ID? Does it have a balance key? Okay, what is the type of the balance key? You have to define all of that upfront. That is what defining your schema means. Put in data that follows that schema. You can't change the schema ever. You cannot be like, nah, I'm going to store a string where a number used to be stored. And update the schema as your application changes and perform migrations. So in SQL database, it's not as easy to change the shape of your data. You cannot just open MongoDB Compass and add a new key in there. You have to perform a migration. You have to tell the database, okay, bro, I am changing something. Please add a new key in the database. Please convert a balance from a number to a string. You have to perform these migrations and tell your SQL database very strictly, okay, right, this is how the schema looks like now. Any data that comes in needs to follow this schema. So there are 4 parts when you're using an SQL database. So if you ever start using an SQL database, it's not as easy as, I started the database and started the Node.js application, started to put data in there. You have to do something extra. You have to first run the database, start it on either a cloud service or locally. Use a library that lets you connect to it and put some data inside. Before you put data inside though, you have to first define the schema. You have to tell SQL, okay, this is what the shape of the data looks like. You cannot start to put data up front. SQL will panic. It will tell you, bro, I don't know, what are you putting? First, tell me what are the tables, tell me what does the shape of a table look like, and then give me data. So if you try to insert without putting in data, it will complain. And lastly, after you've created the schema, after you've told SQL, okay, this is what the schema looks like, is when you can put data in. So the first step always is how to create the database, basically this step right here. And there are a few popular ways. You can use NeonDB, you can use Avian, which I have not mentioned here, but it's another popular cloud service, or you can start it locally using Docker. This is what I'm going to use. And 12.3, video number 12.3 on the dashboard is a good overview of how you can use Docker to run things locally. In fact, you'll find a track here called Actionable Docker, which pretty much shares the same thing. So if you don't understand this command, it looks very overwhelming. Feel free to go to that video and then understand how you can run Postgres locally using Docker and then run it. I'm going to do the same. So let me open terminal here and let me quickly start Postgres locally. Let me remove this -- name because I already had another container with that name, and let me restart. And once I do, it says failed, probably because I already had it running. Yes, let me kill the old one and then restart. And there you go. Now I have Postgres running locally. How do you know, Harkirat? How can you confirm? If I run docker ps, I see there is a single container running right now. This is the ID of the container. This is the image type, so on and so forth. And it's listing on port 5432 on my machine. Cool. At this point, I would urge you to first start, make sure it is running locally, or grab a URL from NeonDB, and only then should you proceed. Have a Postgres database running somewhere so that you can proceed from here. Cool. And once you do, make sure you have your connection string. What is the connection string? It is a string which has your username, password, your host, and database. Basically contains all the details of your database. If you go to NeonDB or any cloud provider that gives you a database, you will find this connection string there. So this is the connection string. If you click on the I over here, it will show you the password, and that string is what you can copy. And that string contains the way to connect to your database. That contains your username, which in my case is 100x steps, your password, which is a bunch of stars right now, your host, where it is hosted, and the name of the database. So whenever you start a database in a cloud provider, it will give you this string. If you start it locally like we did using Docker, then the connection string would look something like this. If you ran this command, and if you gave the Postgres password as this string right here, which is my secret password, you can give it whatever you want. Then the corresponding connection string is this. Postgres is the username. My secret password is the password. Localhost is the host where it is running. This is the port where it is running because that's the port mapping we used. And then Postgres is the name of the database. All of this I've covered where in actionable Docker. So if you want to understand how I was able to create this connection string given this Docker command, you can go to the video on actionable Docker right here. This connection string is very similar to the MongoDB connection string. If you remember, how did we get a MongoDB server? We went to mongodb.com. We created an instance and it gave us back a connection string. The connection string of MongoDB also contains, a username, a password, things like these. And similarly, for Postgres also, this is our connection string, which has a username, password, host, so on and so forth. If we understand this is when you should proceed. If not, make sure you chew some glass a bit and are able to get a database up and running and the corresponding connection URL, which could be this if you're using Neon, could be something else if you're using a different service. If you're starting it locally, if you used this command, then the corresponding connection string would be this. Cool. Let's proceed. Next up is using a library that lets you connect to it and put data inside it. So there are like various ways you can connect to a database. So if this is your database that we've just started, let's say you've started it locally just like me. So this is your Mac machine or whatever Windows machine, and you started a database here that's listening on port 5432. Now, if you want to actually insert some data, you can use various libraries. One of them is PSQL, which is a CLI. What is a CLI, Harkirat? Command line interface. It lets you connect to the database using your command line. What is the command line, Harkirat? Your terminal. If this is my terminal, and if I run PSQL, which I do have locally, you might not. If you don't have PSQL, you can either install this, or I'll show you another hack if you want to, learn some more Docker today. You can run the following command with me. Run docker ps first, and then copy this container ID, and then run docker exec -it, paste the container ID /bin/bash. I repeat, docker exec -it, the ID of the container /bin/bash. Pause the video, run this command. Once you do, what you see over here is you'll see the name changed. It's no longer week 12.4. It is root @ of something. I was able to get inside the container of mine. What happens when I run docker, run this thing? I start a container. What happens when I run this command? I'm able to SSH into the server. I'm able to run commands inside the server. If I press ls here, it does not give me my week 12.4 folder's contents. It gives me the contents inside the container. So What is the benefit of using this command? It lets you run bash commands inside your terminal, inside your container. And why is that good? Because PSQL exists already as a CLI here. So even though the way to exit this, by the way, is exit. So you come back to your folder. Even though you might not have PSQL here, you will have PSQL in your container, because when you started your container, you started it using Postgres. You got the Postgres image, and the Postgres image does have PSQL already in it. So you can always, if you don't want to install PSQL locally, just SSH into the container, or more specifically, run a few commands in the container and give it your host name, your port, and basically you can use the PSQL command. If I go back to the slides here, what does it say? It says you can connect to Postgres using this specific command: PSQL -h your host, -d your database, -u your username. What was our host, if you remember? It was localhost. What was our port, if you remember? Database. It was Postgres. What was our username? It was Postgres as well. Hakirat, how was the database Postgres? How was the username Postgres? Go back a slide. What was the final connection string that we had created? It was username, password, host, and database. So both the database and the username were Postgres. The password was this my super secret password. If you press enter over here is when it would have asked you for the password. It did not, which is even better. And now you're able to run commands in this specific, PSQL shell. So what have I done? I did a few things here. Let me quickly share. Let me exit out from everything. Let's quickly revise what we had done. I told you, you can use a library that lets you connect to PSQL, your Postgres database, and put data inside your database, get data from your database, so on and so forth. PSQL is one such library. What does it say? It says PSQL is a terminal-based front end to Postgres. What does a terminal-based front end mean? It means I can run commands in a terminal to put data inside the Postgres database. It provides an interactive command line interface to Postgres SQL. With PSQL, you can type in queries interactively, issue them to PostgreSQL, and see the results. It's basically let you put data and get data from your Postgres database. Question is, how do you run PSQL? And the answer is either you can install it on your Mac, on your Linux, which I already do have, so I don't have to do anything fancy. But if you don't have it in your Mac or in your Linux, what you can do is you can run docker ps and see, okay, this is the container that I'm running. You can tell Docker, I want to run some bash commands on it. You will reach this terminal, and here you can run PSQL with the right host name, the right database, and the username and the password. You don't even have to give, and you're good to go. You should see something like this. If you see something like this, it means you are good to go. You can start to write queries like insert into some tables, so on and so forth. Or, for example, I can write select now, and it shows me the current time on this database is this. So that is one way for you to be able to connect to a Postgres database. If this Docker exec path seems very complicated, you can just install PSQL locally on your machine. /q to exit. And you don't have to go through this complicated Docker logic, but this is just another way for you to run PSQL without installing it on your machine. Cool. So that's one way for you to be able to connect to your database and run commands in it. What's the other way? It's the PG library, which is a Node.js library. Just how Mongoose exists for MongoDB, PG exists for Postgres. It lets you put data inside a database by using Node.js library, by using the Node.js runtime. If you have an Express application in the end and you want to put data in a Postgres database, PG library is one such library you can use to do it from the Node.js runtime. Cool. All right, let's go back a few slides. What were the steps I said? Running the database, we have done that. Using a library that lets you connect to it and put data in it. We have seen PSQL. We have seen PG. The third is creating a table and defining its schema, which is the next thing we have to do. You can connect to your database. Let's try to put some tables inside. Since I said SQL is very strict, you need to tell SQL, okay, bhai, this is what my table will look like. There will be a users table, a to-dos table, an admins table, so on and so forth. You have to run SQL commands and tell the database, okay, this is the shape of the data that you should expect. So let's do that next. Let's see how you can create a table and define its schema in Postgres. All right. If you remember from the class, the syntax that I shared for creating tables looked something like this. I have detailed explanation of what each and every line means, but let me share very quickly that if you would want to create a users table in your SQL database, how would you create it? This is the SQL command that you have to run. SQL stands for Structured Query Language, which basically means it is a programming language, very similar to C, C++. And this is the syntax of that programming language for you to create a table in your database. So if I run the psql command, if I copy over this code and paste it here, you will see it says created table or create table query ran. If you now run /dt and semicolon, which basically means show me all my tables, you will see it says users has been created as a table. So you run multiple such commands initially to tell SQL, to tell your Postgres database, okay, this is what my database look. These are what my tables look like. There is a users table, to-dos table, admins table, so on and so forth. You also give the shape of the table very strictly. Okay, the ID is serial, which means 1, 2, 3, 4, 5 keeps on going up like this and is the primary key. Username is unique and not null, and it is a varchar, which means a string with a maximum length of 50. Email string with a maximum length of 255, also unique and not null. Password, varchar, not null, but password is not unique. Password, 2 people can have the same password, but email 2 people cannot have the same. Username needs to be unique. Email needs to be unique. Password cannot be, it doesn't necessarily have to be unique. And created at, when was this specific entry made? And the default value here should be the current timestamp. This is just the syntax of SQL to create a table in your Postgres database. Harkirat, what happens if you have to add a new key here? Let's say you want to add city over here, the city that the user is in. You can use the alter command, alter table users add column, something like that. There's like, you can Google it, or like very simple query for you to add more columns to your table. And that's how you change the schema of your table as time goes by. You can go through all of these points in detail if you want to understand what each and every line over here means. We covered this in the original video as well. In the end, there's a call out. Let's see what it is. If you have access to the database right now, try running this command. I do have access to the database, so I ran this command to create a users table. Next up is interacting with the database. Again, if I go back a few slides, what were the 4 steps that I shared? I said running the database, we have done that. Using a library, we've started PSQL. Creating the tables, I did create the table as well. I have run this specific command. So the only thing that's left now is running the queries on your database to interact with it. Let's do that next. Interacting with the database. The way to insert something in your database is using this insert into syntax. Again, this is all syntax of SQL. Okay, this is how you use the structured query language to tell your database that you want to put something inside. Insert into the users table, the username, email, and password, for which is this thing, this thing, and this thing. That's how you put data inside your database. If I copy this and paste this here, you will see it says insert 01, which means 1 row has been inserted into your table. What does 0 mean here, Harkirat? Good question. Let me quickly Google that. Probably means the number of rows that were updated. Oh, the OID is always 0. It is used to be the OID which is assigned to the inserted row. If count was exactly 1 and target table was declared with OID 0, but creating a table with OID is not supported. Basically, will always be 0, it seems. So the number of rows that were inserted, and this number will always be 0. Cool. All right. Next up, updating a table. So now that you have inserted something, let's first look at the select. Let's see how you can explore your database. How did we do this in Mongo? We opened MongoDB Compass, a GUI like this, and started to explore it. Postgres also has a bunch of GUIs like these. The famous one is called pgadmin. So you can download pgadmin, put a URL like this here and connect to your database. Or another way to explore your database is just running the select query. So I'm going to run that next. Select star from users where ID equal to 1. This is the query that I'm running. And what does it return back? If I expand this a bit, it gives me back, Harkirat, there is one user with ID 1, the username of which is this, email is this, and password is this, created at is this. Can I change this query a bit? Yes, you can be like select star from users. You cannot give it a where query. You can be like, give me all the users. Now, in our case, we only have a single user, which is why you only see a single row. But if I had multiple users, I would have seen multiple users over here. Let me actually add a few more users. We change the username and the email. Let me insert another user. Now, if I do a select star from users, I see 2 rows, so on and so forth. How else can I change this? You can be like, I only want to select username and email. I don't want all the rows, and then you will only get back username and email. So that's how you can use SQL to selectively fetch things from your tables. That's what we're doing over here. Next up, we have the update query, which lets you update data in your database, update the users table, set password equal to something new, where email equal to something. A very common query you might run if you're exposing a change password functionality. So if I run this command and then again select all the users, you will see the password has been updated to new password for the user whose email was user@example.com, which is this user right here. Cool. And lastly, delete, which is pretty self-explanatory. You can run the command delete from users, and this will delete all your users. So don't run this command. Add a where clause. Delete the user where the ID is 1 so that a single user is deleted. Now, if I run the select query, it says I only have one user because I deleted the other row. Cool. That's pretty much it. That is how you can interact with your database. These are the 4 common commands that you will usually run in any full stack application. The next question is, how can you run the same queries from a Node.js runtime and not, using PSQL? This is fairly simple, but in the end, you have a Node.js application which will have an Express server that the user will hit. So how can I, number one, create, a Node.js application or an Express application which the user will hit from their browser? Let me put browser over here. And then how can this Express application then hit your database and put data inside, fetch data from the database, so on and so forth? Let's discuss that next. All right. Let's understand how can you run the same queries using a Node.js application. As I mentioned, PG is one library that lets you connect to a Postgres database and run any query you want on it, be it an insert, a get, an update. And this is the syntax for it. You can also always go here and look at the client-side APIs from here. I've sort of chunked them down and put them here. Import client from the Postgres library, initialize client and give it the necessary hostname, database, username, password. You can also do something like this and give it just the connection string. You don't have to give them independently. Either one of them works. And then the way to actually run a query is client.query and then send the insert, the delete, the update command. So let's try this out quickly locally. So I'm going to copy this and initialize an empty TypeScript project. Would urge you to do the same. So open Visual Studio Code and maybe first open a terminal. And open this in Visual Studio Code. Once you do, run the standard commands to initialize an empty TypeScript project. Command number 1, as always, is npm init-y, and command number 2 is npx tsc-init. Then go to tsconfig.json and change the root dir to /source, change the out dir to /dist, and create a folder in the root, call it src, and add an index.ts file here. Now comes our journey of actually writing the code that connects to a Postgres database. The first thing you have to do is npm install the PG library. Make sure you bring it locally so you can actually use it. And then let's copy over this initial code that I had written, which does what? If you look at the code, it calls a create users table button function, which first we initialize a client, and then after doing a client.connect, we call client.query with a create table query. I had already created the users table, which is why this query will fail. I'm going to replace this with users2 so that I create a new table, because I had already created the users table using PSQL over here. You'll see it's beginning to complain here. It says cannot find a declaration file for PG. What is a declaration file, Harkirat? You should go to week 12. The video which says deploying npm packages covers what a declaration file is, high level. The answer is that you have to bring the types of the PG library locally as well, which you can do by running this command. If you want to understand better what this is, what is a declaration file, go to a video in week 12 called monorepos and introduction to like deploying npm packages and introduction to monorepos. Cool. Now this seems like the code is fine. Let's look at it one more time. I import capital C client from PG, which is a class that lets you initialize a client. I give it the connection string, which is my Postgres connection string. The password is my super secret password. If you created a NeonDB database, that is what you should put here. If you created an Avian database, you should put that connection string here. Since I started it locally, that is what I'm putting here. Then I created a create users table function, which when I call does a client.query create table command and then logs the result. Let's see if this works or not. The first thing to do is tsc-b to compile the project, and then node dist/index.js to run it. If I run it, I see command create result. Seems like it has worked as expected. The result that I've logged over here does not show any errors. If I run the same thing again, what would happen? It would try to recreate the users2 table, which already exists, which is when I would actually see an error. Here it says, an error relation users2 already exists. But the first time it did not give me an error because it did not exist. Cool. That's how I can send a create table command. And what's the next thing to check? If you want to look at the code again, this is the code for simply creating a table. Now we need to understand how to send an insert query, a get query, an update query, so on and so forth. So let's go to the next slide and see how you can send all of them. Initialize an empty Node.js project. We've already done that. Install the PG library. We've already done that. And then the first one says, create a simple Node.js app that lets you put data inside. Make sure it's an async function and you are doing a client.connect before you actually do the insert. Let's try to write this together. It says the function should be called insert user data, and it should do a first client.connect. And then we should insert some data in the users table. What was our users table? If you remember, it had a username, string, password, string, email, string. These were the three things that you can put in a database. If you remember, username, email, and password. This has a default value. This has a default value. Question is, what query should you run here? Harkirat, it should be something like this. Insert into users, username, password, email, values, the actual values, which, okay, this is one syntax to write it. If you understand this tilde syntax of writing dynamic strings, then you might understand this. You might not as well. So let me share what exactly this means. I think I've created this string very quickly. Okay, do you understand this? You probably understand this. 1, 2, 3. So This is one way for me to run an insert query. Insert into users, username, password, email, and then the values are 1, 2, and 3. The value for the username, which can just be user, the value for password, which is 1, 2, 3, the value for email, which is this. This works, but we want a dynamic input. We want whoever is calling this can pass in a username, a password, and an email. So how do I take these values and put them here, here, and here? You might say, Harkirat, you can use string concatenation. You can be like, let initial query equal to this. And then you can, concatenate the things. You can be like initial query equal to initial query plus username plus single quote plus password plus single quote, so on and so forth. You can dynamically create this string like this, or a much cleaner way to do it is if you're using tildes over here and not double quotes. What do I mean by tilde? This thing right here. Then you can dynamically put variable names here by using this syntax, $ bracket open bracket close. If I put username inside, it will get replaced in this part, which is exactly what we want, right? We want over here, whatever is the input user comes. So you can say $ bracket open bracket close username, then same for password, and then same for email. Cool. This is an insecure way of writing the query, but this works. Why is this insecure? We'll discuss very soon. But I run a client.query, insert into users, username, password, email, values are these 3. Harkirat, are you saying this will work if I write let name equal to my name is name or whatever email? No. If you put it inside double quotes, then it won't work. Then JavaScript will think like this is your part of your string. But if you put it inside tildes, is when JavaScript will understand, acha, my name is the actual dynamic value of email should be replaced over here, harkirat@gmail.com. So that is when this syntax like this works. If you put it inside tildes, if you put it inside double quotes, it will not work. All right, cool. So hopefully you understand this. I was able to create an insert query, and if I run this, most probably it should work. Let's see if it works or not. Let me run this code locally. And if you look at the logs, it says command insert row count 1 OID 0. What does this mean? One row has been inserted, which means it worked as expected. I can also confirm this by running, again, docker exec followed by psql followed by select star from users. If I see a new user has been created, 123 is the password, this is the email, and this is the username, which tells me this query did work as expected. Can you guess what will happen if I run this command again? It says duplicate value violates the unique constraint. I cannot put it again because a user already exists with this username. What if I change the username and email? Then it will work. If I recompile and rerun, you will see another row has been inserted. If I go to PSQL and rerun the select star from users, you will see I have 3 users now. Cool. That is how you can run an insert query. But I mentioned this is slightly insecure. Why? Because this username and password and email is something that the end user will provide you. In the end, you're creating a full stack application, and whenever the user signs up is when you get the username from them and you put it here, password from them, you put it here, email from them, you put it here. And there is a common attack vector called SQL injection, where someone comes and gives you an erroneous username. If someone comes and they give you this username, right? Semicolon, delete star from users. Then what will username get replaced by? It will get replaced by where semicolon, delete star from users, semicolon. And then password could, let's say, be empty and email could be empty. So what did the final string became? It became insert into users. The values are nothing, or if it can be something more, the username can be extremely created in a way that the final query looks pretty legit. The final query looks something like this. Values, this thing, comma, empty, semicolon, delete star from users. If the user wants, they can fabricate the input away so that the final query becomes this. And then you send this to the database. And the database feels like, acha, these are two queries, an insert query and a query to delete all the users. And it will delete all the users from your database. This is what's called SQL injection, because the user is injecting some SQL. They're not giving you simple strings. They're giving you SQL and they're able to inject it into your query. To avoid this is when you should use a different syntax. Whenever you're getting values from users, whenever you're getting username, password, email, anything else from a user, this is not the syntax you should use. The syntax you should use is this. You should be like, insert into users, username, password, email, and the values are $1, $2, and $3. What does this mean? This means SQL, you are telling SQL, okay, I'm going to put 3 values here. Make sure you consider them as strings. Do not consider them as SQL syntax. When you write an SQL query like this, you tell SQL, okay, this is a variable, this is a variable, this is a variable. Whatever I write inside, whatever I give you for this, consider that to be a string. Do not consider that to be SQL. And then you can pass the 3 values that you want here as arguments. You can be like, username is $1, password is $2, email is $3. Now, even if the user gave you some erroneous value like this, that is what will finally reach the database. If I run this, you will see the user gave you some SQL like syntax. I think you don't need double quotes here. Duplicate query. Let's make this 1, 2, 3 ABC. And let's try one more time. Email key is duplicate. Email was the third one. We change that. Let's try one more time. And you will see it is inserted. If I open my terminal, you will see the last one has semicolon delete from users as the username. That string finally reached the database. That string wasn't parsed as SQL syntax, which is why you were able to avoid a common attack vector, a common vulnerability called SQL injection. Cool. So what did we learn from this? Okay, this is the right way to write an SQL query in Node.js. What is the wrong way? The wrong way is what we wrote initially, which was something like this. This is the wrong way. This is the right way. Why? Because the second way is prone to SQL injection. How, Harkirat? Well, the username you are taking from the user and putting it as such. This can be any string. You are telling the database, okay, bhai, this is the final query. And you are letting the user fabricate that query. You are letting the user be like, password is empty. Let's say the user sends you, password is empty. Email is empty. And username is single quotes, comma, single quotes, comma, single quotes, close, and then delete from users, semicolon, and then another select star from users where, or another insert. They can very meticulously give you the first argument, design the first argument in a way that the final thing becomes 2 queries or 3 queries. And then SQL just feels like you gave them 3 queries. SQL doesn't know that this thing was actually something that the user gave you. And so it doesn't understand that it should parse all of this as a string. It just parses it as SQL, and you let the user inject SQL into your database. To avoid that, the syntax you use is this. Okay, it does not matter what username you give me. I am telling the Postgres table, okay, bhai, you take this as a string. Doesn't matter if the username looks like this, select star from whatever, does not matter. You will put this as such in the database. Do not parse this as SQL, which is why this syntax is better than the other one, and the one you should prefer when you're writing Postgres queries. Cool. All right. That was all for the first 9 slides. You can go, and there are a few other things to do here: how to query data, how to update data, so on and so forth. You should try things out here. You should try to write a bunch of insert queries, select queries, update queries. I'm not going to do this for this video. We've already covered this in the live session. Next up, let's understand relationships and transactions and how you can create relationships in an SQL database and how can you create transactions. All right, now comes the meat of today's class: understanding relationships, transactions, and joins in SQL tables. Relationships let you store data in different tables and relate them with each other. Many times you might have a use case, for example, a use case like this, where there is a user who has an email, a name, and an address. The address itself having a street, city, country, pin code. The user having multiple addresses, not just one. So this not just being an object, but being an array of an object. And whenever use cases like these come, in case of a NoSQL database, it's pretty simple what needs to be done. You say addresses is an array of object. Over here, it's just an object because I assumed there will be a single address for a user. But let's say the user could have multiple addresses. Then what would you do? You would convert this into an array and you're good to go. NoSQL database is very schemaless, very flexible. You can shove everything in a single row. But can you do the same in SQL databases? Let's see. Since MongoDB is a NoSQL database, you can store any shape of data in it. If I ask you to store a user's detail along with their address, you can store it in an object that has the address details, this being that object. But in SQL, you cannot do that. In SQL, there is no way for you to, have a table called users, let's say, which has an ID, a username, an email, a password, and an address, which is an object. Unfortunately, SQL doesn't let you, you can actually put very complex objects like this in a single row, but you shouldn't. You should not shove all of this here into a single row here called address. You should do one of two things. You can either make the users table longer. You can be like users table has ID, username, email, password, and then country, pin code, city, so on and so forth. That approach will work if the user has a single address. I repeat, if the user has a single address, then you can be like, haan bhai, the users table has the username, ID, username, password, email, and then pin code, city, country, so on and so forth. You can say this. But when will this approach fail? Can you guess? I can totally be like, everything will be in the users table. Users table has the user's normal detail and as well as address details. This approach will fail when a single user has multiple addresses. If a single user has multiple addresses, what will you do? Will you put 2 entries for that username here? Will you be like, the user ID is 1 and ID is 1, but the first address is present in the first row, second address is present in the second row. This is a conflict. The ID needs to be unique. You cannot put 2 rows here with the same ID. So how can you store 2 addresses for the user? The short answer is you cannot have pin code, email, city, country in this row anymore or this table anymore. You will need to put it in a different table. So your final schema looks something like this. You have a single entry for a users table and you have a separate table called addresses, which has the following entries. It has the ID of the address, the user ID for which this address is for, and then the pin code, country, city, so on and so forth. So what does this tell you? This tells you, okay, now I can have multiple addresses. I can be like address 1, address which has ID 1 and user ID 1. And then pin code, so on and so forth, and address 2, user ID 1, pin code, so on and so forth. I can relate data. Ki haan bhai, this address is for this user. This address is also for this user. How was that determined? It was determined using this user ID field. If the user ID here is 1 and user ID for another row is 1, that means this address is for this user. This is how we are relating data together. And what were we learning? We were learning about relationships. So what is a relationship? In SQL, you what's called normalize your data as much. You break your data down into various tables such that the addresses table has a foreign key to the users table. You say by user ID is a foreign key. Whatever ID is present here, it represents a row in a different table. And if I have multiple entries for that row, that is fine. That means this user just has multiple addresses. A single user could have 3 addresses, 4 addresses, does not matter. As long as the user ID here is 1, that means this address is for that user. And this is how we are relating tables together. These are what are called relationships. So what are the two things we have learned? Relationships and foreign keys. What are relationships? Whenever you have multiple tables and you want to relate data amongst them, you want to say that the address row here is for a user in this table. That's what a relationship is. What is a foreign key? The key in the second table, which helps you relate data in the first table. The key which uniquely identifies a row here is what's called a foreign key. Whenever you define your addresses table, you can explicitly say that user ID here is a foreign key to the ID over here. You can say that the user ID here is a foreign key to the ID over here, so that whenever you put data in the addresses table, SQL does checks. SQL makes sure that you are not putting any random ID here. Whenever you try to insert an address, if you have told SQL that user ID is a foreign key to ID, SQL will make sure you cannot put an ID over here that does not already exist. If you try to put in any data which does not exist for a user that does not yet exist, SQL will stop you right there. That is why it is always a good idea to mention that user ID is a foreign key to ID over here. How do you do this in the SQL syntax? It looks something like this. I create a users table just like we were creating it until now. Username, email, password, nothing new. This table right here. And when I create the addresses table, along with all the fields that I'm adding, an ID, a user ID that will let me relate to this table, city, country, pin code created at, I in the end say foreign key user ID, which means this thing right here, references the users table ka ID field. I say create a foreign key for user ID or this specific entry right here, this specific entry right here, that points to the ID in the users table, that points to, that references the ID in the users table. And in the end I say on delete cascade. We'll get to what this is, but do we understand everything here? Okay, I created a users table normally, I created an addresses table normally, but in the end I said okay, the user ID here is a foreign key to the ID over here. The foreign key user ID references users table ka ID. Cool. One extra thing I missed was on delete cascade. What does this mean? This basically means that if I ever delete the user one, if I ever call a delete query that looks like this, delete from users where ID equal to 1, what should happen to all of these two addresses that have been related for, let's say, this user? If the user one had 2 entries here, should they also be deleted? What do you think should happen? If your user ever leaves your platform and says, I want to delete my user account, you should ideally get rid of these two as well, right? You should delete this row. You should also delete these 2 rows. And that is exactly what on delete cascade means. It means anytime this is deleted, cascade the delete to anything that references it so that your data is cleaned up very well. If user one left, you don't just delete this. You delete this as well. You delete this as well. Harkirat, can I do something else? Can I do on delete something else? Yes. You can do on delete restrict, which basically means okay, if there is any foreign entry for this user, restrict deleting them. You can literally be like, if nahi bhai, first delete addresses, first delete all the references and only allow this. If this said on delete restrict, then even if I try to delete this row, SQL won't let me. It will be like first delete all the foreign references and only then can you delete this. Cool. I've said a lot of things. Let's try to actually implement them and see if it actually works. I had already created the users table. Let me quickly create the addresses table in PSQL. This is the command to run. I already had the users table. I created the addresses table. Let me insert some values inside. I already have a user with user ID 1. Let's see, maybe I don't. Maybe I deleted it. Select star from users. I have a user with ID 2. I don't have a user with ID 1. So let me just take this query and add an address for the user with ID 2 because a user with ID 1 does not exist. Let me add another address. New York 2, USA 2, and that's it. Now, if I select star from addresses, semicolon, you will see I have two addresses for the user with ID 2. What happens if I delete the user with ID 2? If I do a delete star from users where ID equal to 2, what do you think will happen to the addresses of this user? Don't need a star. It says deleted 1. It did delete my user. If I select the users table, you will see a user with ID 2 does not exist. The question is, when I deleted this, did these get deleted as well? Did the addresses that I created for this user get deleted as well? How did I initialize the foreign key? I said on delete cascade, which basically means if I now select the addresses table, I see no entry here. Why? Because the delete cascaded to the addresses table as well. If I deleted something here, that delete propagated to anything that referenced it, and that is why addresses table also got empty. Harkirat, what if I initialize the table with on delete restrict? Let's try it out. What can we do? Let's create another table. Let's call it addresses 2. So create table addresses ki jagah, let's do create table addresses 2. And here, let's not do on delete cascade. Let's do on delete restrict. And run this. Now let me add some addresses. But in what table? The addresses 2 table. Oh, user with ID 2 does not exist anymore. So ID 3. Inserted. Let's see our users table. It has 3 entries. Let's see our addresses table. Or more specifically, addresses 2 table. It has 2 entries. Now let me try to delete from users where ID equal to 3. Yeah, 3. What do you think will happen? Will it let me delete the user with ID 3? It does not. Why? It says update or delete on users violates the foreign key constraint, this thing on table. This detail ID 3 is still referenced from the addresses 2 table. It says, I will not let you delete the user with ID 3 because someone is referencing it from address 2. And when you had created the address table, you said on delete restrict. If you remember, when I was creating it, I said on delete restrict. I restricted the deletion of addresses 2 or of the user if something references it in addresses 2, which is why I'm not able to delete it. How will I delete it, Hakirat? You will first have to delete all the values from the addresses table. Addresses 2. And now if you want, you can delete it from the users table. I first had to explicitly delete the addresses and then I could delete the users table. So on delete restrict is a little more, as you can see, strict. If you want, if you want the user to first delete everything from everywhere and only then allow them to delete their account is when you should use on delete restrict. If you have a simple application, you want to allow the user to just click a button and delete their account and all the data related to their account is when you should use on delete cascade. Hopefully that's clear and you understand relationships in SQL. The next thing we will discuss is transactions in SQL. All right, next up, let's understand transactions in SQL. A quick recap of transactions is Okay, if you want to run multiple SQL queries such that either all of them run or none of them do, is when you use transactions. This was introduced in the Paytm project. If you remember this project right here, transactions become super important in a use case like Paytm, where you want to make sure कि हाँ भाई, if this is, let's say, a balances table and a user sends someone else money, if you are debiting a row by, let's say, minus 50 rupees, you are also crediting the other user with plus 50 rupees together. By together, I mean if the first transaction happens or the first SQL query runs, the second one should 100% run. You can never, or you should never, in a Paytm like application, debit 50 rupees from one account and forget to credit the other account. What do I mean by forget? Why would I forget? I will write the SQL queries correctly. Yes, but let's say the first query ran and minus 50 happened and your Node.js process went down for some reason, or minus 50 happened and your connection to the database closed for some reason. So you should tell the database whenever you are doing transactions, whenever you're doing multiple things together that you want either all of them to run, or if either one of them fails, all of them to roll back, you should tell the SQL table or the MongoDB table, okay, hey, I am starting a transaction. Any query that comes after this, hold it. Don't just run it. When I tell you, done. When I tell you, okay, I have sent you all the transactions that I needed, then run all of them together. Don't run them partially. So whenever you create transactions, whenever you want multiple queries, either all of them run or none of them run, they run atomically. What does atomically mean? Both of these should run or neither should run. If one of them fails by mistake, all of them should roll back, is when you first tell SQL table or MongoDB table, I am starting a transaction. Please make sure whatever queries are coming after, they all run together or none of them work. Then you send all of the transactions, sell all of the queries, and then you tell it done. I am done. Please either do all of them or revert all of them and tell me what happened. Were you able to do all of them or were you able to revert? And that's how you do transactions in the real world. So it's not as easy as sending two queries. You actually send, one query to tell, I'm good to go. I'm sending you multiple transactions. Then you send multiple SQL queries and then you tell it, I am done with my SQL queries. Please commit to the transaction. Please do all of these things. Or if you weren't able to do it for whatever reason, please tell me you weren't able to do it so I can handle the error correctly. That is how you should do things in a Paytm-like application. Or even here, let's say, a good question to have at this point is what queries are run when the user signs up and sends both their information and their address in a single query. We created an addresses table. We created a users table. We created two tables. When the user is signing up, they will send you their user details and their address details. They will fill up a form similar to, facebook.com. If you go to facebook.com and try to sign up, it makes you fill a form, right? If I click on create new account, 1, 2, 3, 4, multiple things it asks me. It'll probably ask for the address as well here. And when they click on sign up, what should happen in our application? Some data should be put in the users table. Some data should be put in the addresses table. A good question to ask at this point is what queries should run when the user signs up and sends both their user information and their address information in the single request? Do we send two SQL queries to the database? What if one of the SQL queries fails? You don't want partial data to go in, right? If the user signs up and gives you their address, you want their user information should go in the users table. You want their address information should go in the addresses table. And if either one of these requests fails, you want the complete thing to fail. You want this entry also goes away, this entry also goes away. For a use case like this would require transactions in SQL to ensure that both user and address information goes in or neither does. Very similar to the Paytm app. You tell SQL I'm starting a transaction. You tell SQL here is the user's information. There, put this in the users table. You tell SQL put this in the addresses table, and then you say commit. You say I am done, and both of these queries either run or none of them run. Let's see it in action. Let's see how you can create transactions in SQL. This is how it works. You first tell SQL begin. You tell SQL I am starting a transaction. And now you tell SQL all the queries you want to run. Let's say I want to run this query right here. Cool. Even though it says insert 01, and insert hasn't happened yet. I repeat, and insert hasn't happened. If I open another terminal, let me open another terminal on the side. And here, let me go back into the Postgres container. Let me so where did I insert? Let's see, let's open them side by side. I inserted John Doe in the users table. Let me select star from users. Select, oh sorry, I first need to do PSQL and then select star from users. And here, notice John Doe hasn't reached the users table yet. Even though I ran the insert query, even though it said insert 01, I don't see it here. Why? Because I told SQL, ki bro, a transaction is coming. I'm going to send you multiple things. Don't commit yet. Don't put anything in the table just yet. I'm going to send you multiple SQL queries. I've sent the first one. Let me send the second one. Still nothing has happened. Still the users table will be empty. After I commit, which is, the last thing I said here, done, is when SQL will be like, okay, committed. Now something has been put in the users table. Now something is put in the addresses table. If I select star from users, I see John Doe has been inserted. Cool. So what should you do when a user gives you both their address and their user information? You should ideally start a transaction and put both of these one by one. And even if one of these fails, you should tell the front end, okay, error while signing up, please try again. Or if both of them succeed, then you're good to go. Cool. That is what transactions are in SQL. And this is the Node.js code for the same thing. If you look at it, we connect to the client, we send a begin, we send the first query, we send the second query, and then we send commit. That's how basically send 1, 2, 3, 4, one by one. In Node.js, you can also try it out here in PSQL. But of course, in the real world, you would use Node.js or Golang or whatever your backend language is to send this transaction. Cool. Hopefully that clears things. If you want to, see this in action, you can try this. Okay, here is a way to confirm this actually works. Let me send a begin and let me insert into the users an entry for someone that already exists. I repeat, this user already exists. John Doe already exists. John Doe 1 already exists. So this query will fail, right? If I run this, and then if I try to run the other one, which was the any query. Let me try to run any query. I ran an RNS query. As you can see, it also gave me an error. Let me run another non-RNS query, which is correct username and correct password, a unique username and email. And then let me commit. As you can see, roll back. If I try to find something with this ID in the users table, I will not be able to. I don't find them. Why? Because the second insert, even though this is a legit insert, this happened inside a transaction, and there was another query that happened in the transaction that failed, which is why any other query that you do in this transaction will not work. Cool. That is what are transactions. Super useful in a use case like Paytm or a use case like this, where a user is going to sign up with two things, their address and their user's information. And you need to make sure both of them reach the table together. Either both of them reach or none of them do. Cool. That's it for transactions. Next up, let's understand joins. All right. Lastly, let's look at joins. What are joins? Why do you need them? And what are the various types of joins? Defining relationship is easy. The thing that we did in the last slide, that's easy. Add a foreign key constraint and say that addresses is related to the users table. For example, what is hard is joining data from two or more tables. For example, if I ask you to fetch me all the users details and their addresses, what SQL query would you run? If I ask you, give me a user's username, email and password and give me their address details, would you do this? Harkiyat, I will run one command first to get the user with ID, let's say 8. or 5, let's say. This is the first command I will run. And then this is the second command I will run. Okay, give me all the addresses for the user with ID 5. Or can you do something extra? What is the problem with this approach? Problem number 1 is you are sending 2 queries to the database. So you are doing a round trip to the database twice. If this is your Node.js application and this is your database, you are telling the database once, okay, please give me all the user details. The database is returning you. Then you are again hitting the database, okay, please give me all the address details for the user. You're getting it back. So you are doing 2 round trips to the database, which is bad. What is another problem in this? The another problem is, what if first you run this query and then some data changes in the addresses table and then you run this query? There is no referential integrity in your request. So too hard of a word, referential integrity. There's no, you don't know, sorry, transactional integrity, not referential integrity. There is no way for you to know, okay, when you send the first request and got back the data, before you send the second request, something might have changed, right? So whatever you had in the first one might be slightly stale than when you're sending the second request. To fix this problem, when you know 2 tables are joined together or 2 tables are related to each other and you want joined data, by which I mean you want data from both of them together, you can use a join query. Let's see what that means. The query here says select users.id, users.username, users.email, and addresses.city, addresses.country, addresses.street, addresses.pin code. So select a few things from users join addresses on user.id equal to address.userid. So it's no longer select something from users table. It is select something from users join addresses on these constraints. What does this mean, Harkirat? What happens when you do users join addresses on some constraints? What happens is, okay, if this is table number 1, let's say the users table, this is table number 2, let's say the addresses table. When you do, okay, give me all the, let's say there is data here and it is related to 2 queries over here. So there are 2 rows here for addresses. Both of them have foreign keys to a single row over here. When you have data that looks something like this and you want to return the user joined data. What do I mean by joined data? I mean, you want the user to see username, user ID, let's say, email, password, and city, pin code, so on and so forth. You want all of this data to be joined together and to be returned to the user, is when you use this syntax. What does the syntax say? It says select all these things, whatever you need, ID, username, email. There are a few things that I wrote here, username, ID, email, whatever you need from the tables, from not one table, but users join addresses on constraints. This part is important. Okay, we are now joining both the tables. What does joining mean, Kirat? It means combining both the tables. What does join mean? Join means combine 2 tables, but we don't want to combine it in a random fashion. We don't want that, if there is one row here, it gets joined with all the rows here. And then there's the second row here, it gets joined with all the rows. We want to join on a certain constraint. We want to join on user.id equal to addresses.userid. Only for the rows which follow these constraints on both of these tables do we want to join and put the data together in sort of a third table that we return to the user. Let's try to run this query and see what it does. Select from users join this where user ID equal to 1. Let me change it to 5. You will see no row gets returned. Very fishy, Harkirat. You said you will run this query and you will get ID, username, email, city, countries, everything. You will get the user details also. You will get the address details also in a single row, but it is returning 0 rows, Harkirat. Why? Because if you look at the addresses table, it only has entry for a user with user ID 10. If you look at the users table, it has a user with ID 5, it has a user with ID 10. Since the user with ID 5 has no row here, our join statement says, bhai, I could not find anything with this constraint. I will return you 0 rows. When you are using join, it needs to have at least one row that matches these constraints for it to appear in the final result. Since in our case, the user with ID 5 has no entry here, is because of that reason, there is no output row here. What happens if I change the join statement to give me everything for the user with ID 10 now? Then I see one row. I see one row with joined data, ID 10, username this thing, email this thing, and their address. That's what joins let you do. In a single select statement, I was able to get all the details for this user if they have a single address. Let's say they had multiple addresses. Let me add another address to this table, insert into addresses. Let me just copy this query and then this one as well. And let me replace the user ID with 10. Now the addresses table has two entries for the user with ID 10. It has two addresses for the user with ID 10. And now what happens when I run the joined query? Do you think there will be one row or two rows here? There are two rows. It gives you both of the addresses for this user joined with their user information. This part is the same. User information is the same for the user with ID 10, but addresses are different. They are same right now because I put the same value in the addresses table, but in the real world, user will have different values. You will see different values here. That is what joins let you do. Why are they useful? Why are they good? The reason they are good is because in a single query, you were able to get back the user's information and the addresses information in a single materialized sort of a table. This thing right here, without worrying about, two separate SQL queries. Cool. That is what joins let you do. Benefits of a join: reduced latency, simplified application logic, because you write a single SQL query, and transactional integrity, making sure that even if both the queries go together, so there is no difference in an insert that might have happened between the queries. There is a single query which is going out. Another slightly cleaner syntax to look at this is this. So this and this do the same thing. If rather than writing from users, I write from users u, and rather than writing join addresses, I write join addresses a, then when I am selecting, I can simply write u.id, u.username. I don't have to write users.id, users.username. So this is a slightly cleaner way to write the same thing, so that you don't have to write big things like users, and addresses again. You create a shorthand for them by writing from users as u, from addresses as a. Cool. Both of them do the same thing. And again, this is the approach in Node.js. It's as simple as writing a query like this, and then, doing a client.query. Of course, it makes sure SQL injection is not possible. If the user is giving you the ID, it is passed in as a variable over here. We are not putting it raw in the string. Cool. That is what joins are. But there are various types of joins. For example, if you remember, if I tried to do this select star for the user with ID 5, I got back no rows. I got back no rows because when you do a join, it only the rows which have one entry in the users table and some entry in the users table and some entries in the other table come in the final thing. For ID 5, there is an entry in the users table. There is no entry in the addresses table, and hence no row appears over here. For address 10, there are two entries in the addresses table, which is why I see two values over here. So when you are using join, let's read through what it says here. It says returns rows where there is at least one match in both the tables. That is what join or inner join do. Both of them mean the same thing. If you do a join or if you do an inner join over here, let me write inner join instead of a join. It gives me two rows. if I write just join, then also it gives me 2 rows. Both of them are the same thing. Join by default is inner join. And what is inner join? Returns the rows when there is at least one match in both the tables. If this is table number 1 and table number 2, if there is an entry here for something and there is an entry here for the same thing, is when the joined data appears. You cannot have, an entry over here and no entry here. If you have no entry for a user's address here, then you will not see it here. But if there is an entry for an address here, then you will see those rows here if you use inner join. There might be a use case where you want कि Harkirat, even if there is no entry on address for a user, I want to see that user. I want to see all my users irrespective of whether or not they have an address here. If they have an address, great, give me the joined data. If they don't have an address, put null in their address, but I want to see them. That is where left join comes into the picture, returns all the rows from the left table and the matched rows from the right table. So even if there is an entry in the left table, which does not have a corresponding value in the right table, it will appear in the final result. Let's try it out. Let's replace this with left join. And now if I run it, for user 10th, it will of course appear. Let's see if it appears for the user with ID 5. And you will see, I now see a row for a user with entry 5. Even though there is no entry in the addresses table for them, all of these become null. So if you want to see something, even if it does not exist in the right table, is when you use left join. And of course, right join is vice versa. If you want to see an address, even if the user does not exist, then you will use right join. Left and right basically means, this is the left table and this is the right table. If you do a left join, you will see every entry on the left table, even if the entry does not exist in the right table, and vice versa. If users exist on the left, addresses exist on the right, and I write right join, then I will see all the addresses irrespective of whether or not they have a corresponding value in users. Now, since we have the foreign key constraint over here, whenever there is an address, there will be a corresponding users, which is why right join does not make sense. That's what I mentioned here as well. Given the structure of the database, a right join would be less common, or actually not common at all, since the addresses table is unlikely to have entries that are not linked to a user. It is highly unlikely, in fact impossible, for us to have an entry over here that does not have a corresponding entry over here. So right joins don't make sense, because right joins, they make sense. When you have something in the address table, you want that thing in the final result, but that thing does not have a corresponding entry in the left table, is when right join makes sense. Since in our case, that is never possible because address has a foreign key, right join does not make a lot of sense. Lastly, full join. Can you guess? There's just one thing that is left now. We have done the entry should be in both the places. We have done the entry should be in the left place. We have done the entry should be in the right place. What is full join? The entry can be in either. Returns rows where there is a match in one of the tables. It effectively combines the result of left join and right join. Basically, if you want to see everything, irrespective of, there is a match, there isn't a match. If there is a match, great. Show me the joined data. If there isn't a match either on the left table or on the right table, still show it to me, is when you use full join. Full means give me everything. I don't care if, there are 3 entries. Let's say there are 3 entries here. And then there are 2 entries here. And they are not related at all. I repeat, this is not related at all to any address. And let's say theoretically, no address is related to a user. If I do a full join, I still want to see 5 results. I still want to see 5 results, jisme first 2 rows will have user data and no address data. Last 3 rows will have address data and no user data. So if you want all the data, irrespective of how they're connected, is when you use full join. So in our case, if I run full join on the users table on addresses, all right. The reason we saw a single row here, even though I just said, there are 5 entries here, you should see all 5 of them. Can you guess why? Why did I see a single row here? Because I have a constraint at the end of my join. I have a where statement. I want all of this, but only for users with ID 5. If I remove this constraint, is when you will see all the rows. You will see the user with ID 5, the user with ID 10 and their corresponding address, the user with ID 10 and their corresponding other address. So if you want everything from both the tables, irrespective of the relationships, you use full join. If you want everything that has at least one value in both the places, is when you use inner join. As you can see, user 5 exists, but since they don't have an address, we don't see them in the final results. We only see if every row is filled over here. That's what inner join does. Left join is, okay, if there is everything from the left table should come. Users table, even if they don't have a corresponding entry here, they will come. This guy did have a corresponding entry, so you saw that. If it did not, you would have seen one row at least for them with null values over here. And right join is just the opposite of it, where you want every entry from the right table to at least come, irrespective of whether or not they have an entry in the left table. Cool. That's it for joins. And that's it for Postgres or SQL basics. There are a few advanced things we have missed. For example, normalization, indexing, that we will be covering in 1 to 100. With that, let's end it. I'll see you guys in the next one. Bye bye.